Hello, good evening, friends. Welcome to 360 Digit MG interview preparation session. So, give me a minute. I'll just share my screen. So, today we'll be starting with clustering. So, we'll start with clustering. So, what is clustering? So, clustering is an unsupervised machine learning. In this, this is a task which involves automatically discovering of natural grouping of data. Like when we are dealing with supervised learning, we are predicting there, but with the clustering algorithms, not only interpreting the data, we are just interpreting the input data and just find the natural groups or clusters in the feature space. And this cluster analysis is also called as data segmentation. Why? Because here we segment the data into different homogeneous groups. This is also an exploratory method. And in this cluster, we find out the homogeneous groups of different records. So that is what clustering. Then we have how many types of clusterings. There are many more kind of clusterings we have in our machine learning algorithm, but mostly we are using or dealing with hierarchical clustering or k-means clustering. So what is hierarchical clustering? What is hierarchical clustering? So hierarchical clustering is first of all, hierarchical clustering is also known as hierarchical cluster analysis. So we can also name it as HCA, hierarchical cluster analysis, which is also a cluster analysis, and this seeks to build a hierarchy of clusters. Like with the clustering, we are forming the clusters of different data points. So with that input data points, when we are doing the clustering, then in the hierarchical clustering, we are building the hierarchy of the different clusters without having a fixed number of clusters. So in this hierarchical clustering, again, we have, it can be divisive clustering, divisive hierarchical clustering, or agglomerative hierarchical clustering. These are two methods which we follow in hierarchical clustering. But apart from that, we have some other hierarchical clustering methods which are birch, cure, chameleon. So other hierarchical clustering methods are also there, but mostly we are following the divisive or agglomerative clustering. So, so the next question is, what is agglomerative clustering? So the agglomerative clustering is nothing but it is also we name it as bottom up approach. In this, we are following a number of data records, and out of that we form the clusters, and finally we reach up to one cluster. So for that reason it is known as bottom up approach. So this clustering algorithm doesn't require any pre-specification of the number of clusters. So this bottom up algorithm treat each data as a singleton cluster. So at the outset, and then successively agglomerates pairs of clusters until all clusters have been merged into a single cluster. So that contains all the data in one cluster finally. So that is agglomerative clustering. Then we have divisive clustering. So what is divisive clustering? So this is just opposite to the agglomerative clustering. So in agglomerative clustering, that was bottom up approach, but this divisive divisive hierarchical clustering is top down approach. So here what we do is, this algorithm also doesn't require to pre-specify the number of clusters, but the top down clustering requires a method for splitting a cluster that contains the whole data, which proceeds by splitting the clusters recursively until individual data have been split into singleton clusters. Just opposite to the agglomerative clustering, there we just take all the single data points and form the clusters, and then merge all the clusters gradually and make a one cluster only which contains all the data points. And just opposite to the same, we have the divisive clustering, in which we have one clustering. So out of that we will be splitting it into different clusters, and finally we will be getting into singleton clusters that will be every single data point will be splitted separate. So that is divisive clustering. So in hierarchical clustering, we have different type of linkages. So what are the different type of linkages? So we have 4 types of linkages. So those are, one is single linkage, then the second one is complete linkage, then we have average linkage, then last one is we have centroid linkage. So what is single linkage? So these are all the linkages in which we measure the distances between the data points or between the centroids or between the clusters. So on the basis of that, we will be making the linkages. So as per the name, single linkage is also called as nearest neighbor. This is nothing but the minimum distance between the members of the 2 clusters. When we are measuring the minimum distance between the members of 2 clusters, so there we are taking single linkage into consideration. Why? Because we are doing the single linkage from 1 to 1. So it is single linkage. Then what is complete linkage? From the name itself, we can understand it is also called as farthest neighbor. So this is nothing but the maximum distance between the members of the 2 clusters. In the single linkage, we were measuring the minimum distance between the members in between 2 clusters. And in the complete linkage, we are measuring the maximum distance between the members of 2 clusters. So this is the farthest neighbor. This is nearest neighbor. Then after we have average linkage. So average linkage is average of all the distances between the members of the 2 clusters. When we are measuring the in between 2 clusters, so there are the distances between all the members. So it is measuring the distances between all the members. So 1 to all. So after that, it is taking the average of those distances. So it is called average linkage. And then after, finally we have centroid linkage. So this linkage is the distance between the centroids of 2 clusters. When we are forming a cluster, so in every cluster there will be one centroid. So when we are measuring the we are doing the centroid linkage, so it will be the distance between from one centroid to other centroid. So that is the centroid linkage. So the next question. What are the various type of clustering algorithms? So we have a number of various types of clustering algorithm, out of which we have, first one is connectivity based clustering. Then we have centroid based. This connectivity based clustering is nothing but the H clustering, hierarchical clustering. So then after centroid based clustering, this is also called as partitioning method, which is partitioning method. Then we have distribution based clustering. Then we have density based clustering method. Then we have fuzzy clustering. Then we have constraint based clustering. This is also called as supervised clustering. Supervised clustering. So we have 6 types of clustering algorithms. Out of that, even we can have some more, and in from these categories we'll have some subcategories also. So here we have only 6 models which we use. So next, what is k-means clustering? K-means clustering. So k-means clustering is a method of cluster analysis using a pre-specified number of clusters. In hierarchical clustering, we didn't require to pre-specify the number of clusters over there, but in k-means clustering, we need to pre-specify the number of clusters. So here it requires advanced knowledge of k. So here k is nothing but the number of clusters we want to divide our data. So we will be choosing or pre-specify the number of clusters into which we will be clustering our whole data. So if we are doing, we are taking it as 4. So our k is 4, suppose. Then we will be making 4 clusters out of our whole data. So that is k. K value is the number of clusters. So here we need to so k-means clustering majorly we are using, but even we are using k-medians and k-medoid also. And when we are having only categorical data, then we are using the k modes. Here k means is for the numerical values, and we can use k mode for categorical data. Even fuzzy modes also we can use for the same. And when we have mixed data, like we are having categorical and numerical data in one, like mixed up for a data set, then we use K prototype. So we use K prototype for mixed data. And when we have non-convex shape of data, then we use the kernel method. So kernel k-means method is also there. That is, in that we use polynomial, Gaussian RBF, sigmoid kernel functions. So all these we use when we have a convex shape of data. So there are some other types of K methods also, which is Pam, Clara, Clarence. So these are all subcategories of methods. Those are also kind of K methods only. So what are the advantages of hierarchical clustering? H clustering. Advantages of clustering. So this helps in easy handling of any forms of similarity or distance. So when we are using H clustering, then it gives us the ease of handling of any form of similarity or distance. And is it also consequently applicable to any attribute types. So if we are having any features in our data set, that is also like acceptable in this H clustering. So that is advantage for this H clustering. So we can take any attributes and we can work on the same. Consequently, applicability to any attribute types. So here the disadvantage is the main disadvantage here is it requires the computation and storage of n into n distance matrix. So here n is nothing but the number of records we are taking. So the major disadvantage is it requires the computation and storage of n cross n by n matrix, distance matrix. So n by n distance matrix is there. So for every large data set, when we are working on large data sets, so it will be very expensive. This can be very expensive and slow. So this is the disadvantage for hierarchical clustering. What is the advantages and disadvantages of k-means clustering? What is the advantages and disadvantages of k-means clustering? So the major advantage for k-means clustering is the convergence is guaranteed. Here we are sure that we have the convergence of the data. So convergence of the data is guaranteed. Then it is specialized to clusters of different sizes and shapes. So it takes any size and shape of the clusters. So that is the main thing over here. So it specializes to cluster of different sizes and shapes. So these are the two advantages for k-means clustering. So what is the disadvantage? So the disadvantage is here we have the k value. So the k value is nothing but the number of clusters which we need to pre-specify. In hierarchical clustering, we don't need to pre-specify any number of clusters over there. It will create automatically the number of clusters. It will group the records into the different clusters. But here in k-means clustering, we need to specify the number of clusters. So which is very difficult to predict. So k value is difficult to predict. And one more disadvantage for k-means clustering also, it does not work well with the global cluster. When we are working with the global cluster, it doesn't work well. It does not work well with the global cluster. Then next, what are the applications of clustering? Where we can use the clustering? What are the applications of clustering? So we can use clustering for recommendation engine. Recommendation engine. So with the measurement of similarity within the groups and the dissimilarity between the clusters. So those distances when we are measuring and we are grouping the data sets. So it is applicable when we are recommending any product to a customer. So for that recommendation engine, it can be applicable. So that is one application. After that, when we are doing market segmentation, even there we can apply clustering. Market segmentation. Market segmentation. A segmentation is also a kind of clustering to group the things. So here also we apply clustering. Then after social network analysis, when we are analyzing the social network, then we need clustering. Social network analysis. Research result grouping. Search result grouping. Search result grouping. So here also we are working with the grouping. So we can apply clustering algorithm. Then in medical imaging, so then image segmentation, then anomaly detection. So these are some applications of clustering, which where we can use clustering. Even for other models also, for optimizing other models also, we use clustering. So this recommendation engine, market segmentation, social network analysis. So these are all some of the uses or applications of clustering. What is the difference? What is the difference between hierarchical clustering and k-means clustering? What is the difference between hierarchical clustering and k-means clustering? We have already discussed about the hierarchical clustering and k-means clustering. So what is the difference? So the difference between k-means and hierarchical clustering is, as we know, clustering is a subjective statistical analysis. So there is more than one appropriate algorithm for every data set. There is no specific that this is the appropriate algorithm for the same. So we can have more than one appropriate algorithm for same data set or same type, same problem. So how to choose between k-means and hierarchical clustering? So if there is a specific number of clusters in the data set, so we have a specific number of clusters in the data set, but the group they belong to is unknown. Then we choose k-means. Like we have the specific number of clusters. If the number of clusters is known, that is visible, that we can find out easily, then the group they belong to is not known. In that case, we can choose k-means. If the distinguishes are based on prior beliefs, then hierarchical clustering should be used to know the number of clusters. So here we don't have any distinguishes which is on the prior beliefs for the data set. So we don't know the number of clusters here. Then we are going for hierarchical clustering. So when we have a large number of variables, so k means compute faster. As we already discussed, in hierarchical clustering, we are computing n by n matrix. So where n is the data records, so number of records will be n. So when we are dealing with a larger number of variables, then it will be easier to compute faster and faster with the k-means clustering. And the result of k-means is unstructured. The result of k-means is unstructured, but that of hierarchical is more interpretable and informative. When we are doing hierarchical clustering, we can interpret the data in a good manner. We can get the insights from the data very clearly. So as per the clusters, we can, as per the hierarchy of the clusters, we can get the insights and we can get the clarity of the clusters from the same. But with the result of k-means, it is not structured, so it is very difficult to get the insights from the data. But it is easier to determine the number of clusters by hierarchical clustering's dendrogram. So when we are using hierarchical clustering, then before that we do the we create the dendrogram. So when we plotted the dendrogram, from that we can conclude how many clusters it can be it can give. So that much clusters we can take for our model. So the applications of clustering are found in a large number of domains of our unsupervised learning. So that those are the difference between supervised hierarchical clustering and k-means clustering. Next is, what is recommendation system? What is recommendation system? So recommendation system are a subclass of machine learning which generally deal with the ranking or rating the products. So recommendation system, on the basis of the past information, past data, what we get from the social networks and all, on the basis of that, we will be predicting the like a product which can be recommended to a customer. So that is recommendation system. Recommendation system is a system which predicts ratings a user might give to a specific item. Why we use the recommendation system? What is the benefit? What are the benefits of recommendation system? With the help of recommendation system, the users also finding the items of their interest easily. When you are using recommendation system, so we can suggest the customers to find their interest of items. So it helps them to provide the item in delivering their items to the right user. So when we are using the recommendation system, with that we can deliver the correct item to the right user, and it also identify the products that are most relevant to the users, and it is also personalized content. So it varies from person to person. So when a person it depends upon the demographic and their past purchase details. So on the basis of that, it has been personalized. So they will suggest what is the correct item for the particular customer. And it also helps the websites to improve the user engagement. When with the help of recommendation system, the customers can be suggested the correct item so that they can be engaged in the website most of the times. So what we what is collaborative filtering? What is collaborative filtering? So collaborative filtering is when two persons have the same opinion. If one person have an issue with a particular product, and even this other person is also having similar kind of opinion about the same, then it is quite probable that for other for other issue also they will have the same opinion. So when we compare the opinion of a person chosen randomly with with both of these persons, so it will be different. So that is the collaborative filtering, where we measure the similarity between the persons. So here we find the similarity between the customers. So with the different customers, the similarity will be found out. What are the different kinds of collaborative system? What are the different types of collaborative system? So we have customer based collaborative system and user based collaborative system and item based collaborative system. User based collaborative system collaborative filtration, sorry. Which is UBCF, and another one is item to item based collaborative filtration. So this is IBCF. So these two types of collaborative systems we have in our recommendation system. So that was all for the day. So thank you for attending this session. Thank you.